What's up, guys? Can you hear me? Hello.
Yes, sir. Good evening, sir.
Good evening, Saurabh.
Yes, sir.
Hey, good evening, guys. Okay, so yeah, so what we have done, guys, not yesterday, last class, we have covered the VPN part, and we have seen that the GRE is basically a clear text VPN. Clear text VPN means what? It does not provide any kind of security, right? Like it doesn't have the ability to provide the encryption, decryption, hashing, those things, right? So that's why we came with the protocol is known as the IPsec, right? So both, if you look for the both GRE and IPsec, the both are point to point, right? GRE is also a point to point, but only the thing is that GRE is a clear text VPN, whereas the IPsec is a encrypted one, right? Now, let's talk about the VLAN little bit, then we'll go with the layer 3 part. So in a VLAN, if you guys remember that, so it's a virtual local area network, right? In a virtual local area network, what we have seen that why do we need a VLAN? For example, if you have a switch, right? And in this particular switch, what happened? We have a multiple users are sitting over there. So user 1 and user 2, user 3, right? And user 4 over there. So what you can do that, understand this concept. So this is the service provider. This is the service provider. And what service provider is going to give that? Service provider is giving the services to the customer. So we have a link over there, if you see that, right? So, one thing, service provider could be the layer 2, right? And it could be the layer 3 as well. So what people always think that, okay, service provider is always a layer 3. ISP is always a layer 3. No, ISP also give you the layer 2 services. ISP also give you the layer 2 services. It's not only the layer 3 services. So take example, if the switch is right, if the service provider is giving the layer 2 services, so what they will do that. So what we want from the service provider. So this is the customer number 1, and this is the customer number 2, right? We want the traffic should be segregated. We want the traffic should be segregated. So what we can do over there, we can just create the VLAN over there. So VLAN number 10, we can do that. VLAN number 20, we can do that. So in that way, what happened? The switch will create the 2 MAC address table, 1 MAC address table for the VLAN number 10, and 1 MAC table for the VLAN number 20. Right? So these are the 2 different MAC address table we have over there. So this is for the VLAN number. So we have a user A, MAC address A, MAC address B, MAC address C, MAC address E, and MAC address F. Again, the MAC address A. Understand the concept. So in the VLAN 10, right, we have a 0 port number, 1 port number, 2 port number, 3, 4, 5, 6. These are the port number. So on the 0 port number, we can learn the MAC A. On a 1 port number, we can learn the MAC address B. And on 2 port number, we can learn the MAC address C over there, right? Same over here. If you see in the VLAN number 20, what happened? On the port number 3, we can learn the MAC address E. On the port number 4, we can learn the MAC address F. And on the port number 5, we can learn the MAC address, again, A over there. Understand the concept, what's happening in the VLAN. In a VLAN, right, we are just creating the 2 different MAC address table on the single switch. On a single switch, what happened? We are creating the 2 different MAC address table. And why do we need of this thing? Because to just segregate the customer network. So we have a customer number 1 and we have a customer number 2. So we just segregated the customer network by creating the different VLAN. So for the VLAN number 10, we have a separate MAC table. And for the VLAN number 20, we have a separate MAC table. The most important thing, what you have to understand over here, this part. The duplicacy, right? The overlapping is allowed. Can you see that? The overlapping is allowed, not here, here. That's the most important, interesting concept of the VLAN. If I talk with a higher level point of view, see, whatever the things that you have learned till now in a CCNA and CCNP about the VLAN, like a VLAN is a logical network, right? It's divide the broadcast domain, right? It get the multiple MAC address table. That's a basic stuff. If I talk with the high level view, right? If you go with the high level interview, they need to explain the VLAN something like this way. Understand, this is the one service provider, right? Service provider just giving the services to the customer, cust 1, cust 2. But the problem is that in the customer number 1, we have a MAC A. Same way, the customer 2, also we have a MAC A. Is it possible that I can put the same MAC address in a single MAC table? No. That's why we created the two different MAC address table. And how we can create the two different MAC address table? By creating the VLAN over there. So on the layer 2, what I'm trying to say that on a layer 2, we do have a ability. On a layer 2, we do have a ability to segregate the customer network. On a layer 2, we do have ability to segregate the customer network by creating the VLAN. How about the layer 3 now? How about the layer 3? If I talk about the layer 3 perspective, understand the concept. What I told you that according to the RFC 1918 address, guys, let me close my door. I'm getting lots of noise. So according to the RFC 1918 address, right, we have a private IP addresses, right? And we have a public IP addresses, right? These are the two addresses we have. So in our private IP addresses, what happened? This addresses can be duplicate, right? So the company can use these addresses, and public IP address must be unique, right? It's a free, right? Free to use, whereas we need to pay some money, right? Need to pay. Now understand the concept. What happened? Take an example. We have a one customer that's router number 1, right? So we can consider it's a Cisco Bangalore, and we have a Cisco Delhi as well, right? So two branch office we have. Same way, we have a, sorry. Same way we have another branch for the Cisco, another branch for the Bangalore. Guys, just understand this concept. This is same like a layer 2 VLAN. Okay, on a layer 2, we can segregate the MAC address table by creating a VLAN. On a layer 3, we don't have a VLAN concept. On a layer 3, we don't have a VLAN. We have something else, but it is the same feature, like what we call working style. So now we have ISP. So take example, this is my Cisco Bangalore. Let me use my different color. I have a Cisco Bangalore, right? Where this guy is gonna use some private network, 192.1.0/24. They can use it 10.1.1.0/24, right? Same way, what happened? This guy, we have it's a Nokia Bangalore, or maybe Juniper. The Juniper Bangalore also gonna use the same network, because a private IP address can be duplicated, right? So they can use it. So this is my router number 1. This is my router number 2. Now, if I talk about this guy, so this guy, Cisco Bangalore, it's gonna use the 2.0/24 network. And this is the 3.0/24 network. And same here, Nokia Bangalore as well. Okay, it's not a Bangalore. It should be the Delhi. My bad. 2.0 and 2.0. Copy and paste. Now we have a Juniper Delhi. Okay, then this guy is a 3.0, not 3.0. Yeah, 3.0 we can, not 2.0 we can use it. And this is also 2.0. Perfect. So this is a Juniper Delhi. Now understand what happened. If I want to provide the communication between the Cisco Bangalore to the Cisco Delhi, right, and Juniper Bangalore to the Juniper Delhi, what we have to do that? We need to take the help of the ISP, right? So we have an ISP in between. So take example, this is my service provider router, right? So now the service provider is going to give you the layer 3 services. This router 5 we have over there. Now this router 5 has a connectivity with the router 1, Cisco Bangalore. Router 5 also has a connectivity with the Juniper Bangalore. Router 5 also has a connectivity with the Cisco Delhi. And router 5 also has a connectivity with the Juniper Delhi as well. So on a router 5, if you see that we have a multiple links as well. So I can consider this guy as a, 0/0. This guy is also 0/0 over there. And this is also 0/0. So R3, R4, R1, and R2. These are my customer routers. This is my service provider router, right? And this interface, we have a 0/1. I can consider just a 0/2 according to the router name, 0/3 and 0/4. Now you tell me one thing. Okay, now you tell me one thing. This is the Cisco Bangalore. So when the Cisco Bangalore is going to send the route, this network, to whom? ISP. What ISP will do that? It's going to maintain the routing table. In the routing table, what he will maintain that? He will learn this route, 192.168.1.0, right? For example, we are going to run the EIGRP protocol over there. So the EIGRP has a AD will be what? Let's make a OSPF right now, the EIGRP. Let's do that OSPF. So for the OSPF, what is the product AD value for this guy? It's a 1110. And the 10.1.1.1.0/24, guys. For this guy, same AD will be there, 1110, right? Now what happened? After that, I'm going to run the routing protocol between the router 2 and our ISP. So I'm going to run the routing protocol over there, is a EIGRP. Now you tell me one thing, what happened? This is my routing table of the R5. When the router 2 is going to send this information to the router 5 via the EIGRP routing protocol, what router 5 will do that? Previously, on the router 5, when the router 5 has received this information 1.0 from the OSPF protocol, it has a next hop as a router 1. But when I'm learned this information through the EIGRP routing protocol, then what happened? This AD value will be changed over there. It's become the 90 now. Now, what will be the next hop? Do you understand what I'm trying to say that? If you have a single router, this single router is only going to create the single routing table. If you have a one router only going to create the one routing table. And in the one routing table, the duplicacy cannot be allowed. So if the Cisco Bangalore is going to learn the route through the OSPF routing protocol, if the R5 is going to learn the route through the OSPF routing protocol, I will put this information 1110. But when I learn this information from the EIGRP, I need to remove the OSPF route because EIGRP AD has a layer lower than the OSPF one. That's the biggest issue, right? In that case, what happened? Understand this concept. In that case, the EIGRP Juniper Bangalore communicate with the Juniper Delhi, but Cisco Bangalore cannot communicate with the Cisco Delhi. I just have a single routing table. In that case, what you can do that? You can inform to the Cisco, hey, listen, you need to change your network now. You need to go with the 3.0 and you need to go with the 3.0 this guy as well. And same thing on this side, you need to change the 4.0 and 4.0. Then you can communicate it. Then I can add this route because this route is now unique. Now I can add this route. But if the route is duplicate, I cannot add it. Simple logic, right? If the router 1 will receive the one route, like a 1.0.0.0.0 with the two different routing protocol, maybe the EIGRP and the OSPF, of course, the router 1 is going to give the preference to the EIGRP. That's a problem in the layer 3 network. On the layer 2, we have a VLAN. A VLAN create the MAC address table, right? Separate MAC address table. So what we can do that? Take example, if you have a switch over there instead of the router, we can do that one thing, right? We can put the, okay, this guy should be the part of the VLAN number 10 and this guy should be part of the VLAN number 20. So I will have a separate MAC tables. I will have a separate MAC table. No issue. But on the layer 3 side, we have a problem. So to avoid this problem,
Hello.
yeah, go ahead.
Aruna, please repeat this. Yeah, router is first preference is EIGRP.
At this point,
Yes, yes.
of course, right? EIGRP has a 80s 90, and this guy's a 80s 110 router is going to pick the lower 80.
Yes, 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 sure.
Got
Thanks.
it? Understood.
Yes.
So that's a major issue. Now you may have again question, hey law, you just explained me like 2 days, 3 days back, private IP address is not routable. And that's why we need to do the NAT. And now we can see that this is the private IP address and you're sending this route through the service provider. Now understand the concept again. If you go with the higher label, right, when you go in the service provider label, you will understand more things. Like at the NP level, I cannot explain everything in a single classes. So I'm just giving the hint over there right now. A service provider, it can be the layer 2 and layer 3 as well. At the same time, a service provider can be the public and private as well. Okay, the normal internet that you guys are using, that's called the public internet, the public ISP. The private service provider, that comes in the picture when you're going to use the MPLS. Okay, that's called the private connection. A lease LAN, that's called the private connection. So on the when you have a connectivity with the private connection, then you are going to exchange this network, private IP addresses. Now, so to avoid this problem, that we are facing right now, we have a concept is called as a VRF. VRF is similar to the VLAN. Understand the concept. VRF is similar to the VLAN. Only the difference is that what VLAN is for the layer 2. That's gonna segregate the MAC address table, create the multiple MAC address table depending on the requirement. VRF on a layer 3 side. That's create the separate routing table depending on the requirement. So VRF stand for, it's a virtual routing forwarding. Always remember one thing, VRF is not a VRF is a virtual, yes. So VRF create the virtual routing, even the VLAN is a virtualization. VRF create the virtual routing forwarding. What it will do that? It create the routing table. Most of the people, what they are saying that in the interview, VRF create the separate router, a separate virtual router. VRF never create a separate virtual router, never ever. The meaning of router means what? They have a dedicated resources. Understood? VRF does not have a dedicated resources. They are leveraging the resources from the main router. So VRF create the routing table. Like a VLAN. Once you put the command VLAN number 10, what they will do that? Have a look over there. If I put the VLAN number 10, what they will do that? They will create the MAC table. Right? Separate MAC address table for the VLAN number 10. Same thing when I say the VRF, CCI, depend on the OS version, the command is totally different. If I talk about the, what we call iOS perspective, I say the IP VRF command. I just put the IP. IP means IPv4. VRF means I'm creating the virtual routing forwarding. I'm creating the routing table. The name of the routing table is what? It's called as a CCI. Now I have created the separate routing table. So already you have already you have a one routing table, which is known as a global routing table. Already you have one routing table, which is known as a global routing table. So by default, understand the concept, by default, all the ports are part of VLAN number 1. Same like that. By default, all the ports are part of default routing table. Or we can call as a global routing table as well. So like that, if you remember that, what happened? If you see that 0/0, 0/1, and 0/2 is a part of the, by default, they are a part of the VLAN number 1. Same thing, what happened? Whatever the ports on the layer 3 side, they are the part of the global routing table, or we can call as a default routing table. It means that once you assign the IP addresses, once you assign the IP address on this particular interface, this particular interface, this particular interface, for example, I assign the IP address on this Windows 1.1.1, I assign the 2.2.2.2.2, I assign the 3.3.3.3.3. What happened? automatically this will be a part of the global routing table. Automatically. So what you can do that, if you have a requirement, if you want to segregate the routing table based on the customer requirement, you can create the VRF over there. With the help of VRF, what we are doing that, we are just segregating the routing table like a MAC address table in the VLAN. So what you have to do that in the VLAN, first you have to create the VLAN 10, and then you need to go under the interface 0/0. I say the switch port access VLAN number 10, right? Like that way. Same thing, what you have to do that, you need to create the VRF, right? So once I create the VRF, then you need to go under the interface, and by default, right, the interfaces are the part of the global routing table. What you can do that, you just need to go under the interface and say the IP VRF. Hey, listen, now this interface should be the part of which routing table? CCA. So now this interface will be removed from the global routing table, right? This route will be also removed from the global routing table, and it will be now the part of the what? CCI routing table. And now after that, I can allocate the IP address on this interface. I said IP address will be 101.1/8. And now this interface will be the part of the CCI routing table 1.0.0/8 over there. So now on a single router, you can see that I have a global routing table. At the same time, I have a CCI routing table. If you have another requirement, for example, I want to create another routing table, I said the VRF, which routing CCNP. And okay, so once I put this command, automatically what happened, you have a separate routing table for the CCNP now. So there will be no route over there, of course. What you can do that, you need to go like that same, like a VLAN. You need to go under the interface 0/1. I said the IP VRF forwarding, which routing table CCNP. And now I can give the IP address 2.2.2.2/8. So now automatically what happened, this information will be removed from the global routing table, right? And it will be now the part of the which routing table? CCNP. So now how many routing tables you have on the router 1? I have a CCNP routing table. I have a global routing table, which is the default behavior, right? I have a CCI routing table. 3 routing tables we have. Same like that on a switches, we create the multiple MAC table, like the VLAN number 10, VLAN number 20, VLAN number 30, like that. Same way we are doing on the layer 3. So on the layer 2 side, we have a VLAN. On a layer 3 side, we have a VRF. One more important part. I mentioned the default routing table. I also mentioned the global routing table. Most of the time when the people are learning the CCNA, CCNP, and VRF and MPLS concept, right? They are just saying the routing table. Okay, they are just saying the routing table. Always say it's a global routing table. Don't say the routing table, say the global routing table. It will create the more impact on the interviewer side. Okay, now why is the default routing table? When you go in the higher level, right, like a data center and service provider level, then you may face this default keyword over there. So don't confuse with the terminology default and global. Why I'm saying this thing? Because when you go for the interview, right, the interviewer has a more experience than you, right? They have a 10 years experience, they have 15 years experience. They did their CCNA in the back in 10 and 2005 always. Okay, you are doing the CCNA NP now. So they can put the question like, okay, tell me what is the default routing table? What you have learned till now? You learn, okay, I learned the routing table. Now what is the default what comes in the picture? So when they will ask you the default routing table, they are asking you global routing table. It means they are asking you what is routing table. Understood? So don't confuse with the words, focus on the concept. Guys, anybody has a question, what is in the term of VRF? Like what is VRF and what is the difference between VRF and VLAN?
So, basically, the VRF is just
Just
exactly like yes, just like creates a virtual routing table, right?
yes.
Uh, uh, inside the uh, within a domain, right? Or
Inside the router.
inside the router.
That's all. Like
Physical.
our switches, we have a VLAN, create the MAC table, same like that.
Yes, I mean it creates its own separate broadcast domain basically
Oh,
inside the router.
great. It's created a separate broadcast domain, same like that. It's created a separate infrastructure. So take example, if you don't have VRF, then what?
Yeah.
What about the memory and process point of view? When we having more routing cables, they are gonna use your normal router memory and the resources, the CPU. They don't have any dedicated one.
So the
We
main
have a VDC. Just 1 minute, sir. Let me
sure.
I forget the answer.
Nasser.
Let me give you the answer of this question. So Nisha, you just asked the question. So they are gonna use the memory and processor point from the main router. They don't have a VRF does not have any dedicated memory and resources. Same concept, right? The VRF, we have a part of the iOS, right? Let me explain you. And I'm coming to the point, Kailash, just give me 1 minute. Same concept in the data center network. So in the Nexus OS, we have a concept, it's called the VDC. Okay. On a VDC, you do have ability, right? It's same, it's not a, we can call it the same like a VR, but it's an advanced version of the VRF, right? So in a VDC, under the VDC, you can create the multiple VRF. Okay. But in a VDC, you can dedicate the hardware resources if you want. But in the VRF, you cannot do that. So on a enterprise network, you are doing the VRF. On the data center network, you are doing the VDC and VRF as well. On a service provider network, like let me put it over like this way. On the XR side network, service provider network, you are doing the SDR. I forget the name, man. Not secure software. No. I forget the name of S, man. It's a domain routing something. So on a different like tracks, we have a different thing. But VRF you will find everywhere. So it doesn't mean that XR service provider router doesn't have a VRF concept. We do have it. Okay, but the flavors, the advanced flavors we have over there as well. In iOS, we just have a VRF, but Nexus, we have a VR plus VDC. We have a SDR and plus VRF as well. Create in right. Okay, I'm so sorry. My bad. Okay, yeah. Yeah, Nasir, go ahead. Question. Nasir, there.
Yeah, I'm still here. Yeah, thanks so much.
You got it?
So what? I forgot my question.
No, not a big deal, man. It happens with me as well.
Actually, fasting, so it's just energy level is very low.
Yeah, I understand.
I will
Anyways,
ask
let
you.
me do the configuration. Then
No
if
problem.
you get a question, just do interrupt me, okay? So take example, if you don't have a VRF, then what you can do that? If you want to achieve the connection between this guy to this guy, then you need to take a separate router from the Cisco Bangalore, like this way. Service provider will give you the separate router. And for the Juniper Bangalore, we have a separate router. So for this route and this route will be stored in the R5 routing table, and this route will be stored in the R6 routing table. So you need to create the separate physical infrastructure if you don't have a VRF. And that's a costly solution, right? Giving a separate router to each company, it's a tedious task, right? So that's why we have a VRF concept, virtualization. I made a recharge, but it's still. So let me see. I do have a project for the VRF. VRF Lite. Okay. You may also heard this term VRF Lite. So if you are using the VRF with MPLS, that's called as a VRF. If you're gonna use the VRF with MPLS, known as a VRF. If you're using the VRF without MPLS, right? It's known as a VRF Lite. The simple meaning, light means what? We don't have a burden over there. So same concept, router 1, router 2, we have what different networks we have, man. It's not a 191 or 100. So let me check my. Okay, and here we go. So what I can do that first, I'll show you the IP configuration of all the data. Let me check, do we have or not? So I think I don't have, great. So let me do it. I'll configure the IP address on the notepad. So on the router 1, we have a config terminal interface 0/0. It's 192.115.1/24. No shut interface loopback number 1. Let's go with the 101. Okay, 10.1.101/24. Okay, no need to put the no shutdown command 10.1.2.1/24. Okay, and that's my router number 2 now. On router 2, we have a same configuration, only we need to change the physical IP addresses. It's a physical interface IP address 25.2. And that's all on the router 2. How about the router 3, man? So on the router 3, if you see that, right? That's my Cisco Delhi 8. On router 3, we have a interface 0/035.3. And this loopback will be 3.1. And this guy go with the 4.1. Then router 3 has done router 4. If you go and router 4, we have a 45.4. This guy go with the 3.4 and 4 as well. That's cool, right? So that's my configuration for the router customer side. On a customer side, we are not going to do anything. We're just going to do the normal configuration. That's all. Normal configuration on the customer side. So let's do the configuration of the router 1. So router 1 is this router. Okay. And here we go. Router 2 as well. Router 3. And router 4. That's all right. So on the router 5, before I'm going to create the VRF, I just want to show you one thing. So if I'm going to enable the debug IP routing, right? Let me show you the first basic information. Interface 0/0. I just went to the interface 0/0, right? I put the IP address will be 15.5. What happened over there? Can you see that I haven't assigned any kind of VRF over there? I just put the IP addressing, that's all. So if I just put the IP address on this particular interface, by default, what happened? This interface, right, will be a part of the global routing table. So if you see, I got some debug right now. I'm adding this route in my routing table. You see that? And that's my default global routing table, man. If you see, that's called the default global routing table. Okay. But what I want, I make sure that this two interface, right, should be the part of the Cisco routing table, 0/0 and 0/F4/0 as well. And the another routing table that I'm going to create on the router 5 as well. That's part of the, this is the part of the Cisco. That's I'm going to create on the router 5. And the another routing table I'm going to create on the router 5 is the Juniper. That's going to go with the F1/0 and the F4/1. So this two routing table we need to create. The first, let's go on the global configuration. Let me remove the IP address first of all. No IP address over there. Okay, let's leave it. I want to show you something else as well on the router 5. So let's go with the router 5. And if I'm going to go with the router 5 right now, I just have a single routing table. If you see that, so IP root, this is the command to check the routing table, or we can call as a to check the global routing table, right? I just have a one dot because I just configure the one IP address on this particular interface. That's why you got the one dot. But if you go in the router 1, I said the router 5, IP VRF CCI, not CCI, Cisco. I'll get the one routing table for the Cisco. You will see the one log message. You see that? Same thing. RIB means what? It's a routing information base. Same command. I said the IP VRF. I'm creating the another routing table, Juniper. Make sure that this name is a case sensitive. So after the another routing table, RIB means what? It's a routing information base. Routing information base means what? It's a routing table. Did I allocate the any interface in this table right now? No, not yet. So like that, once you create the VLAN, then you need to add the interface into the VLAN. Same thing, once you create the VRF, then you need to add the interface to the VRF. How do I do that? So let me write on command on the router 5. What I did on the router 5, I said the IP VRF Cisco exit, IP VRF Juniper exit. Then next command, what I can do that, I just need to go under the interface F0/0. Remember one thing. It's very, very important. I'm the part of the which routing table right now. This interface 0/0, guys. This interface 0/0 is a part of the default routing table as the global routing table. And on this particular interface, I have already allocated the one IP address, which is the 15.1. Not 15.5, sorry. 15.5/24, right? Do you know what happened? Once I'm gonna remove this interface from the global routing table to the Cisco routing table, when I'm gonna move this interface from the global routing table to the Cisco routing table, right? What happened? Whatever the configuration, not the only IP addresses, whatever the configuration that is associated with that particular interface will be burned. So when I'm going to push this interface from here to here, all this configuration will be removed from the interface label. Everything. If you see right now, I do have a IP configuration, right, on this particular interface. Once I'm going to convert this interface into the Cisco routing table, because it's a part of the global right now, I say the interface 0/0 IP VRF forwarding, in which table? Cisco. Can you see that? Removed due to the enabling the VRF Cisco. Understood? So always remember one thing, right? If you have a planning to implement the VRF in your network, don't configure any configuration on that particular interface. If you have a configuration already, then do one thing, copy the configuration from the interface first of all in the notepad, and then enable that interface into the VRF. Otherwise, you will lose your configuration. That's a recommendation part. Not a mandatory, it's a recommendation. If you have a configuration on that particular interface, please copy it and then re-enable that interface into the different VRF or maybe the global routing or whatever. If you're changing the interface from the one routing cable to the another routing cable, please copy the configuration. All done. I deleted the route from the global routing cable. Now I can assign the same command. That's all, man. So IP VRF forwarding Cisco. Same thing we need to do with the on this particular interface. I can use the for. For means it's a forwarding. So now how many routing tables we have on the router 5 right now, guys? Anyone can tell me how many routing tables we have now on the router 5? So 1/0 will be part of the Juniper routing table. So there will be no code in the global routing table right now. I see the IP VRF forwarding Juniper. All that interface. Let me copy and paste. F41. All done, man. Let's copy and paste this. So if you see the debug right now, all good. So I've added the route in my Cisco routing table and Juniper routing table. Can you see that? Cisco,
A
Juniper.
huge routing table, right?
I now have three routing tables. Can you see that? One is Cisco, one is Juniper, and another is the global routing table. But in the global routing table, do I have any interface right now? No. So there will be no route in the global routing table. So if we
So-
check the routing table right now, see that?
Mhm.
So IP root command, this command will show you the global routing table. There will be no route, empty. But if you check
So
the command show IP root, VRF Cisco, you will see the Cisco routing table. And in the Cisco routing table, we have a 15.0 network, which is this guy. And we have 35.0 network, which is this guy.
So one thing I just wanted to clarify, please. You have mentioned Cisco and Juniper, right?
Yeah,
So I mean, what's that mean? I mean, if you please try to explain a little
it's
bit again.
creating the routing table for the Cisco. It's a name. I just put the name over there.
Right.
You can put any name. It's a CCNP, CCI, ABC, which be this, whatever you want.
Okay, so it's just a name, right?
It's
Okay,
just a name, like
that's fine.
we are putting the VLAN 10. So 10 is the identification for the MAC address table, right? So same thing. See, tell me one thing. I just give the routing table. I just give the routing table. How do I identify which routing table for which company? You need to give some identification, right?
Absolutely. But
That's
so
identification that I give the name over there.
the Cisco is uh, basically the Cisco is identifying the router one
Yeah,
and
you
router
can put
two.
the ABC as well.
No, that's fine. Well, what I'm saying is that okay, if you say looking at this scenario, Cisco is identifying the router one and router three, and Juniper is identifying the router two and router four routing table,
Yeah,
right?
exactly. You can say that.
Okay, that is fine. But you have configured the all four routers
These are the
into the
customer order, right? Customer order, no need to do the VRF, right? Customer order. These are the customer.
okay.
Customer, we don't need to do anything.
But you configured the interfaces of
Only
these
the
routers.
VRF you are going to configure on the service provider order. This is my service provider order.
Okay. And all okay, that is fine. So but you have configured the interfaces of all these four routers into into this service provider, right?
Yeah, respective VRF. This two interface, F0/0, F4/0, can you see that? It's a part of Cisco. F1/0, F4/0, it's a part of Juniper.
Right. So what about the global routing?
Nothing they have right now. If I have a requirement, then I need to put that. I don't have, see, there is no requirement right now, right? So it's empty.
Sure.
It's empty.
So basically, what have you done? You configured everything into the service provider router, right?
Right.
Okay. And from here, you will create the VRF,
Yeah.
right? Well, first we have to do the IP addressing. This
Right.
is what
First,
we have to do.
how, okay, tell me one thing. How do you assign the one interface into the VLAN 10? First, you need to get the VLAN, and then you need to add the interface into the VLAN, right? Switch port access VLAN number 10. Same thing. First, you need to get the VRF, IP VRF Cisco. Then you need to add the interface into the VRF, like I did it. I get the VRF
I
first of
see.
all, and then I add the
Exactly like
interface.
the VLANs.
It's
Sure.
like this command is equivalent, you can call as a VLAN number 10. And this command is equivalent to the switch port access VLAN number 10.
Yeah, basically these commands are just for creating the VLANs, VLAN 10,
That's
20 for marketing, finance, etc. Something like that. Just what we did in VLANs. It's exactly the same thing, but obviously it's a different protocol.
it's a late, not a protocol. It's not a protocol. One thing, it's a feature.
Oh.
Never say that protocol. It's not a protocol. It's a feature of the networking. On a
In
layer
route
2, we have a second
in
system
layer 3.
icon. On a layer 3, we have this thing. On a layer 2, we have a virtualization called as a VLAN. On a layer 3, we have a virtualization called as a VRF.
Okay,
Got it?
got it. Very good. Thank you so
Yeah.
much. Yes.
So now if you see the routing table, we have a command for the Cisco. Same thing, if you check the routing table for the Juniper, you can check it. So route VRF, which one? Juniper. If you see the show IP VRF command, you will see the, guys, please write this command. It's very important. So if you see the show IP VRF, I can see we have a Cisco and Juniper as well. We have one interface in the Cisco, another interface in the Cisco, like this two interface, 0/0 and F4/0. And the bottom two interfaces, right? F1/0, F4/1/0 is a part of the Juniper. If you put the command show IP VRF DT, then it will give you the detailed information, which is not important right now because it's a little bit high level, the eye level. So leave it. Yeah, but we have a multiple command. So most important command, the NP level is what? Show IP VRF interface. This will give you the whatever the interfaces are, whatever the IP address is on the interface, and which interface is the part of the which table, inside which routing table. Okay. Now what? Tell me one thing. From the route of 5, can I ping this guy? Help me out. Can I ping this guy? Sort of.
No.
Yes, sir.
Can I ping
No,
the
sir.
15.1? Why?
No, sir.
Why?
Routing
Yes, we can ping.
protocol.
So it's the same 7/8, right? Yes. No. Nisar said the yes. Anyone else?
You need to add
Yes.
VRF routing table to the ping
Okay,
comment.
understand, Nisar. Okay, so let me explain the Nisar. This thing. So Nisar, understand this concept. So this route in the Cisco we have 0/0, the 15.0 network, right? F4/0 we have in this network, Cisco routing table. Same thing in the Juniper we have a from where I'm pinging right now, man. I'm pinging from the global routing table. As the ping, what? 15.1. It will look up in the global routing table. Hey, do I know about the 15.1 network? Global routing table says, hey, I have no idea because my global routing table is empty. So the ping will not work. Because by default, when you see the ping, it will perform the lookup in the global routing table. So when you have a VRF configured on the router, you need to add the VRF keyword. So I say the ping, I will say that, hey, listen, check the what? Check the Cisco routing table when you're going to send the traffic to the 15.1. So now instead of lookup for this guy, now it will perform the lookup in the which routing table? Cisco routing table, and Cisco has it out. Got it, Nissan? Understood? Great. Okay. Next question. So we did the ping from here to here. Can I ping this guy? From the R5, can I ping the 10.1.1.0?
No,
Why?
there is no routing protocol.
There is no routing, right? There is no routing. So we need to enable the routing because the Cisco does not have a route for this guy, right? This R5 routing table Cisco doesn't have a route. So we need to do the routing. So let's do the routing for the VRF. So I'll start with the static route with VRF. And I said that on a route of 5, we'll say that, okay, so normally what I can do that, I say the IP route, I say the 10.1.0/24, right? And the next one will be, if I'm going to put this command, what happened? If I'm going to put this command on the route of 5, it will put this route in the global routing table. I need to mention that over there. Hey, listen, put this route in the Cisco routing table. Same thing for which guy? Same way we have a 2 more network. Sorry, on the route of 5 for the Cisco side, it's a 10.1.3.0 because ISP also need to send the traffic to the Cisco Delhi. On the same thing on the route of 5, I have a few routes in the Juniper routing table too. So I need to change the Juniper. Make sure that your name is a case sensitive. So you don't need to change the anything. So on the Juniper, we have the same network. We just need to change the 25.2. Wait. This guy also should be 25.2. This guy should be 45.4. All
So
good.
static routing is purely for the reachability, right?
We just do the reachability because I cannot check the routing here. Do I have a on the R5? Do I have a route for the 1.0 in the Cisco? No, right? We just need to provide it reachability. That's all.
Okay.
Now, so
No
this
worries.
is for the done for the route of 5 now.
This is done for the router 2 and 3, right?
We have to do that.
Yeah.
So now you can see the so IP route VRF Cisco. I have a Cisco routing cable. In the Cisco routing cable, I have a route. And same thing, we have a VRF routing table for the Juniper as well. We have Juniper routing table. So the most important thing that you need to see is what? Let me put the command. Can you see that in a Cisco routing table? So this is the Juniper routing table. And we have a Cisco routing table as well. On a single route of 5, I have a duplicate route.
Sorry, where?
On a single route, we have a duplicate route. See that? By default, it's not possible.
No, no. How come they're not duplicate, right?
There's a duplicate, man. It's a 10.1.2.0, 10.1.2.0, 10.1.3.0, 10.1.3.0, 10.1.4.0, 10.1.4.0. Only the difference is that it's a part of the Cisco, upper is a part of the Juniper. It's a duplicate, right?
Oh, yes, that's right. Yeah. How come?
With the help of VRF. By default, it's not possible. That's a feature of the VRF.
I see. So that's the
Now,
whole conclusion.
yeah, go. Sorry, I'm sorry. Yeah, go ahead.
That is the whole conclusion.
That's the
That's
whole
the
conclusion, man. So now I can send the traffic. I said the ping. I said the 10.01.01.01. I need to put the VRF first of all. Ping VRF Cisco. So from the service provider, I'm pinging to this guy. And I can ping the ping VRF Juniper to this guy as well.
Check the IP route. There is no space between the Juniper and the IP address. That's why it is not accepted.
This is space you're talking about?
Yeah, for Juniper, there is no space in the IP route.
No, that's not a so IP.
No. Go ahead. Go to the notepad.
I haven't
yeah.
Yeah,
That's
that's what
Nishant. That's just
Juniper and the IP.
mapping error.
The second.
oh there was
Yeah,
a
there.
like that. Okay. My bad, man.
But it did come up, right?
No, it's net
Yeah.
not came up. Now it's gonna pick up. Still not. Why? Have a route.
You need routing in the router too.
I'm checking that. Thing we are up. Thing we are up to Juniper. Let me ping the next hop IP first of all. Next up has some issue, man. So let me check what's the issue on this guy. Okay, my bad. So I badly wrongly identified the 0/0. It should be part of the 1/0. Got it? No IP address. Now it's gonna ping. There we go. Yep, and this guy as well. Perfect. So now from the route of 5, we can send the traffic to this guy and this guy as well. This guy to this guy as well. Can I send the traffic from here to here? Is it possible? Anyone?
Yeah, I'm sure you can.
Anyone can tell me? Is it possible? Can I send the traffic to Cisco, Bangalore, Cisco, Delhi?
Yes, you can. Yeah.
How? RF1 doesn't have a route, man.
No. I mean, you done the static routing, right?
I haven't done yet, so we need to do that.
No, you done through the R5.
We just done on the route of 5. We need to do on the customer side as well. So on the route of 1, which network I want to go? I want to go the 10.1.3.0. And next up will be 15.1. 5, sorry. Got it?
So the next hop will be the 35.3, right?
No, always the next neighbor IP address. And a customer side, you're gonna do the normal static route, nothing else, no fancy, no VRF. Next hop always will be the neighbor IP address.
Been telling us last 4 months.
Yeah, man. And he still forget. It may you're not guys are realizing.
Yeah, this is not acceptable, right?
Yeah. Yeah, it's not like that. Like, if there is some scenario where you need to configure the 35.3 as well as the next hop. When you go with the, like, when it comes in the service portal, then I'll teach you that part.
No problem.
See, everything is there, and everything is possible in the networking. You just need to play with the networking. That's all. 10 or 3.
Just find,
Yeah.
find the way around.
Yeah. So you guys are right now the label of the professional. When you go come with this expert label, then you need to play with the more with the policy part, like route map, ACL, and BGP and MPLS.
Next year, same time, same day.
Yep.
Maybe
25.5.
different level.
Yeah, 25.5 this guy. And on a radar 4 as well, we have IP route 10.1.1.0. 1.30.45.5. Let's go with the 45. That's all right. So radar 1 should be the go with this guy. Then we have radar 2. Oh, sorry, radar 3. Let's do that. Radar 2 as well. Now it's good to go ping, right? So now from radar 1, I can send the traffic to radar 3. So if you go to the radar 1, and I can ping this guy 10 or 1 dot. So if you see on radar 1, I can send the traffic to the 10 or 1 dot 3.3, 3.1, source will be 10 or 1. So try to understand when this guy is going to create the packet, how the packet will be created, right? How the packet will be structured. So you have a source IP address is 10.1.1.1.1, distance 10.1.3.1. That's a source and destination. When this packet comes to radar 1 will perform the routing table lookup. He said, hey, do I know about this guy 3.1? 10.1 or 3.1? Yeah, according to my routing table, I need to forward the packet to whom? I need to forward the packet to the 15.5. But from which interface? Then I need to do the double lookup. So in the double lookup, what happened? I need to perform the recursive lookup. I need to see which exit interface I need to use it. So if you see that, do show IP route. Now I'm going to perform the lookup for the 15.5. So if you go on the 15. So first I did the lookup for the destination part. I got to know that I need to forward the packet to the 15.5. But from which interface? Then I perform the lookup for the 15.5. I got to know that I need to use the 0/0. That's a recursive. Remember the static route. We did this part. So I need to forward the packet to the other guy, right? When the radar 5 will receive this packet, on which interface? On a 0/0. So what R5 will do that? R5 will receive the route, this packet, right? On the 0/0 interface. 0/0 is the part of the Cisco routing table. So radar 5 is going to perform the lookup in the which routing table? Cisco routing table. So Cisco said, hey, do I know about the 3.1? Yes, according to our routing table, I need to perform the lookup in the routing table 3.0. I need to forward the packet to the 35.3. The first lookup I did for the destination. Second lookup I'm going to do for the exit interface. So 35.3 is going to connect it with the which interface? F4/0. Right? I need to forward the packet to this guy. So now the packet comes to the R3. So this is how the ping is going to work with the help of VRF, with the VRF. So when the packet will receive on the VRF interface, listen to me carefully. When the packet will receive on the VRF interface, it will perform the lookup in the, this is the default behavior I'm talking about, default behavior, because things will be changed when you go with the advanced level. When the packet arrives on the VRF interface, lookup will be happen in VRF table, not the global RF table. So if you're going to ping and this guy, it's going to ping. Here we go. Man, that's all right. So same thing if I'm going to ping from the router 2 to the same network to ping 10.1.3.1. Source will 10.1.1. You can. So Juniper to Juniper, we are able to pick, and Cisco to Cisco, we are able to pick. We are able to submit traffic. This is how you can do the static dot with the help of VRF. Same thing, you can do the EIGRP as well, right? How you can do the EIGRP? So let me remove the static dot first of all on every router. So to do the another routing protocol like EIGRP, you need to remove the route from the static route because the static route has a lower AD. So even if you're going to configure the EIGRP, it's not going to work because static will take the more precedence because of the AD value. I need to remove the route from the R5 as well. So better to do what I can do. I have a 8 route, so I'll just copy and paste it. No, everywhere. Okay. Done. So I did remove the static route. So now let's go with the. You can also do with the RIP protocol as well, but RIP again it's not it's a legacy protocol. That's why we're not using it. So let's go with the EIGRP now. EIGRP with VRF. What you can do that. So you can go in the on the router one side, normal EIGRP you're gonna run. Router EIGRP, I can see that. 100. So I'm assuming that Cisco is gonna run the EIGRP 100. And Cisco is also gonna run the EIGRP 100 on the different side. Whereas Juniper is gonna run the. Let's do one thing. Okay, let's do with the one-to-one protocol. Then we'll it's become the easy. So I'll go with the EIGRP 200. I can do the mix-up as well. I can do the OSPF with the Juniper and EIGRP with the Cisco. But I don't want to do that. Let's make it easy. So router EIGRP 100, I'll say the network is 0 or 0 or 0. Anything is fine, man, right? No auto summary. On router 3 as well. Don't do that in the production network. I'm just doing in the here. Let me make it this way on router 3. Of course, the final 135.0, otherwise it will move from animation. On router 2 as well, I'll just put the this way, just 200, because R2 is having a Juniper and R4 we have. This guy good, router 1, router 3, and router 2, and router 4 as well. Okay, I just did for the practice purpose. Don't do this kind of configuration in the production, not even the examinations. R5 now on a router 5, what you can do that to enable the EIGRP. To enable the EIGRP on an iOS router, you need to put the command router EIGRP, and then you need to define the autonomous system number, right? I can see that autonomous system number 100, or you can use the 1 as well. It's never matter right now. Okay, never matter. You can use the 1, you can use the 100, you can use the 200, anything. So I'm just using the 1 right now. This command, listen to me carefully, because most of the people is getting confused over here. This command is only allow you to enter the EIGRP mode, that's all. And now I will say that on a single data, right, what kind of traffic you have. You have a unicast traffic, right, with global routing table, right, GRT. We have multicast traffic with global routing table, right? Same thing, you have a unicast with the multicast with unicast, sorry, then you have a multicast as, sorry, yeah. Then you have as well what? Then you have a unicast, right, with IPv6 as well. This is for the IPv4, and then you have a multicast as well with the IPv6 as well. So you can see that we have multiple types of families over there. You have a unicast, you have multicast, you have IPv4, you have a IPv6, you have a VRF, you have a no VRF, multiple types of address families we have. So right now, what you have learned till now, CCN and NP label, you just learned the, okay, IPv4 you have. Normally you configure the IPv4 under the interface, right? Under the interface, you just go and say the IP address 1.1.1 and out of here IP network 10.0, something like that. But in networking, we have a different things we have, like a multicasting, we have unicast, we have unicast with the global routing table, we have unicast with the VRF table we have. So you should tell this guy, hey, listen, the next part that I'm doing right now, address family, I'm doing for the VRF, Cisco, right? And now the Cisco is gonna use the which autonomous system number 100 over there. And I will say the network which network 15.0 network 25.0. That's all. On our same thing, I'll just the exit. Now same address family, right? If you see, I just put the one exit. If you put the one exit, you will just enter in the address family mode. Okay, sorry, not address, in the router EIGRP mode. Now it's the address family. It should be 200, and as the network will be what? 25.0, and it will be 25.0. That's all. Understand the concept, guys. This command, right? Router EIGRP1, this AS number 1, it's just allowing you to enter in the EIGRP mode so that you can define the AS number over here, right? So this is for the Cisco and this is for the Juniper. That's all. Copy and paste. Oh, it's an error.
So where did you get this subnet 25.0, 192.160.25.0?
What do you mean where I get it? This is the
I
routing
mean,
R5, right? Submit. We have in the router 5. 15.0, this link. 2035.0.
no, that is fine. I'm talking about the 25.0.
Sorry, not 20, 35 is there. And 45 is there. Sorry, my bad. But the command was given there. Wait. HRP number 1, address family. IPv4 VRF, sorry, autonomous system number. Cisco, I forgot the name of the IPv4. Network asset of 15.0. My name is came up, exit, single exit, and I said the net address family, IPv4 VRF, Cisco. I'm doing for the IPv4, you do have ability, you can do for the IPv6 as well. Cisco Juniper. Autonomous system 200, and as the network, I can put the 0 as well. If you want to use it, you can use it. But let's make a simple way. 45 that's all. Do show run section EIGRP. Let me copy and paste it. I forgot the IPv4 keyword. And here as well. Here's the configuration for the EHRP for the VRF.
Dominant sorry, AS number, they are in BGP, right?
EHRP does use the AS number. Forget the command, you forget the EHRP now again. Practice. EHRP use the, it's a written like a AS number, but actually it's a process number. If I talk about, it's a process number. It's not an AS number. But in a written, it will show you the AS number. So if you go on the router one, if you see the configuration wise, with the command router EHRP, it will show you the AS number over there. But actually, it's not an AS number, it's a process number. So if you go
Okay,
to the show IP EHRP neighbor, I'll show you that.
got it. Thank
It
you.
will show you the process number, not over here. Show IP EHRP proposing. Somewhere it will show you the process number where it's at now. So IP is everywhere it's showing you. One way I have seen that it's a process, but it's not a AS number, it's a process number. How you can verify the command on the router file? On the router file, you have so IP EHRP VRF Cisco neighbor. This is for the Cisco table. So IP EHRP VRF Juniper table. This is Juniper table. So this is how you can enable the EHRP. Same thing, you do enable the OSPF routing protocol as well. How you can do that? So if you're gonna ping, you can ping it. So if you check on the router one, I have a route in my routing table. So on router one, I know about Delhi route. Okay, so same thing. What you can do, if you're gonna ping, you can ping it as well. Source loop back number one. Same way, what you can do that you can enable the OSPF routing protocol as well. So how do you do that OSPF? So OSPF, like OSPF protocol has a two version 2 and OSPF version 3 as well. So the version 2 was introduced in the 90s time. It was introduced only for the IPv4. So there's no other address family. So there's no other, you only do for the IPv4. So if you're gonna do for the IPv4, not for the IPv6, then there is no address family for this guy. So in a OSPF protocol, you don't have an address family for the version 2. So when you put the command router OSPF, you just need to give the router OSPF VRF Cisco, that's all. There's no address family, and then put the network statement, that's all. Version 3 was introduced for the IPv4, at the same time IPv6 as well. And that's why you need to use the address family when you're going to configure those for version 3. The default behavior is what? When you put the command .OSPF1, it's a version 2. So when you're going to configure the OSPF, there is no address family concept. Two hundred. 100. 200. That's a no routing agent. That's all. For the OSPF, what I can do that on the router one, I just gonna put the command router OSPF1, normal OSPF, right? So for the Cisco, I'm gonna use the process ID 1. For the Juniper, I'm gonna use the process ID 2. Area 0. R3. How about the R2? Done. router 4. Right? So router 4 will be into this will be 4. That's all. Router 4 also have a 3 and 4, 3 and 4. That's all. Router 5 we have, as I mentioned, that this guy doesn't have address family, so you just need to put the Cisco over there. I can put a single command to enable both the interface. To network. If you want, you can enable separately as well. Done, right? So let's copy and paste it. Router 1. Router 2. Oh, it's router 3. Okay. Router 4. So router 2 now. Router is a Juniper, so it's gonna use the side 2. It's a slow routing protocol, man. So DRB will be electric, so you need to wait. Compared to the AGRP only. Wait, it will show you the magic. Let's come up now. Right? So now you can check that out. Do show IP root OSPF. R1 has a Cisco Bangalore has a knowledge over the Cisco netting. And even if you check the R2 right now, Juniper Bangalore know about the Juniper Delhi. So if you ping from the Juniper Bangalore to Juniper Delhi, I can send the traffic. So that's how you can enable the OSPF protocol and EAGRP starting out. We'll do the BGP tomorrow, not today. It will become the lots of bulky there now. So let me save this notepad. I'll share this notepad tomorrow. I don't have folder for you guys. Anybody has a question, guys?
Yes, I have a question in regarding the OSPF.
Yeah, go ahead.
So we have configured the EIGRP, which is fine. Then we have configured the OSPF as well.
Fine.
So was wondering why OSPF?
Because initially when the OSPF was introduced, right? This command. So this command is only enabling the version 2. And version 2 it has only supported for the IPv4, not for the IPv6. So if you have only one person, can you call that call as a family? No. If you have more than one person, then you can call as a family, right? A bachelor guy cannot sit at a family person, right?
Basically, you have configured two different protocols on this on the VRF, right?
Not two different. I have committed this one protocol OSPF number 1 and OSPF number 2. OSPF 1 for
No,
the
no, no. We also configured the EIGRP as well, right?
yeah,
Before
man.
that.
VRF, we did the static routing, we did the EHRP, we did the OSPF as well.
Then everything will be showing up on the routing table.
Yeah. No, I removed that EHRP.
So
Before I
you,
configure the
so,
OSPF,
so,
I have removed the EHRP.
okay, that was a confusion.
So
So
can you
you
see
have
that?
to
No routing EHRP
complete.
free.
So that means there's no EIGRP at all throughout this
No,
network.
no, there's no EHRP, man. That's only OSPF right now. Either you can configure the EHRP or the OSPF, right?
Yeah, that's what I was thinking.
Yeah.
So I mean, it's about configuring the OSPF. That means the it has.
Yeah, go ahead.
I don't know what to say. I mean to say the benefits of configuring the OSPF. You
If you're
remove the
asking for the
EIGRP.
benefits for the configure the OSPF, then I think so you need to watch the OSPF videos again.
No. On this specific.
Well, I'm not understanding your question. Yeah, like, can you rephrase it?
Okay, I got your answer.
You got the answer? So you are
I
saying
got
that,
the
okay, what is the difference between the EHRP and OSPF, right? That's your question,
no,
maybe.
I got the answer. Yeah,
Yeah.
I got the answer. Small answer, short
What is
answer.
the small answer?
No problem. That's fine. Okay, so I just wanted to show you the lab I did yesterday.
Oh, the
If you
NATPAD. Yeah, I saw your message.
okay,
Yeah.
can you open the lab if that's okay?
Yeah. He means how to distinguish version 2 and version 3 in the scenario. No,
Yeah,
he
let
was
me,
Karaj. He was just asking like we did the EHRP, then why we did the OSPF again. So that's he was trying to understand the difference between the EHRP and OSPF. Yeah, so Nasir, you have a wrong configuration on router 2.
if
You have removed the IP addresses on the router 2.
you just please give me 1 second. Let me open the lab.